Hi, I'm Simon Green. I'm a cloud architect working for Juniper Networks. This is the first video in a series I'll be giving with my colleague Wojciech, showing you what's possible with Contrail SDN and Kubernetes across multiple on-premise and public clouds. This intro video will give you a quick taste, then the following videos will dive into a number of application use cases. So for these videos we'll be using our Amsterdam laboratory. The architecture is shown here. So we have an on-prem data center running Kubernetes with Contrail as the CNI or network. We're then stretching it out into three public clouds: Amazon's AWS, Google's GCP, and Microsoft's Azure. But rather than keep talking, let's start with a very quick demo just to show you what's possible. So I'm logged into my Kubernetes master. So if we take a look just to see what's already been deployed, you can see we've got no resources running. So in this directory I have 4 small scripts: step 1, step 2, step 3 and step 4. So all of them are very simple. They're just running a number of YAMLs in this directory to deploy applications to do various things. We're not going to explain how they do it. That'll be in the deep dives in the videos that are coming up later. So if we run the first script and then take a look, it's just deployed a MySQL database and a streamer, a video front end. So let's run the second, and let's run the third, and then let's take another look, but this time let's take a look across all namespaces. So you can see that we're creating and have deployed applications in a namespace called deposits and a namespace called mortgages. We've also created a number of services. These get represented as network load balancers inside Contrail, and we've created some ingress, one per application, and these get created as HA proxy load balancers inside Contrail's SDN. And for each ingress we've exposed a routable IP, a public IP. Now let's run the fourth script, and this is very simply just going to scale up the front end of one of the applications. So if we take another look, you'll see it's creating lots of Python front ends. These are acting as our web servers. So what just happened? Well, when we ran that first script, what actually happened is we deployed an application, but the front end, a streamer video server, was deployed into Amazon's web services in London, and the back end was deployed in Google's GCP public cloud in the Netherlands. So at no point did we have to stitch these together. We simply said to the app, find a node in London AWS, find a node in GCP, and the SDN did the rest. And that's across the board, including security, including load balancers, including all those network services you'd be using. The second script then deployed a second application, again between London and the Netherlands. This time the application was spread across Amazon's public cloud in London, GCP, Juniper's own on-premise data center, and Azure's public cloud. This time the application was told to deploy into its own namespace. So when you do that in Kubernetes, Contrail as an SDN will create a project and isolate all the network services for that application. So think of it like a small SDN with all of its own services, routers, switches, load balancers, firewalls, DHCP servers, just for one department. That's essentially what's happening when it creates a project. And the project's isolated from everybody else until you tell it you don't want it to be. And that's with no security controls. Security controls we'll show you later and are far more fine-grained. We then created a third application, again spread across London, Amazon Web Services, and a back end across 3 clouds: our on-prem, Google's public cloud, and Azure's public cloud. All of these applications would be accessed through our SDN gateway, which is in our laboratory, and within the SDN we created an ingress. So it created a load balancer. Its load balancers can be spread across any public cloud. So just to make it clear, there are no rules here. You're just deploying apps and telling them where to go, and Contrail SDN is doing the rest. It can even, for example, have the same network, which is precisely what it did here, sat in Amazon, GCP, Azure, and our on-prem public cloud all at the same time, all with the same gateway. And then we ran the fourth script, and that simply scaled up one of the front ends so that it could handle a bit more traffic. Our load balancer then handling the distribution. So this wouldn't be a very good demo if we didn't show you the end result. When we ran the scripts, we created 3 ingress load balancers. So let's go take a look at the first. This is our video application. And now for our deposits tenant. So you can see this particular application provides a shopping cart. And now for the third application. Again, the same 3-tier spread across 4 clouds providing a shopping cart. So how did we just do that? Well, there's no trickery. Contrail SDN is an overlay SDN, so it represents all of your network services in software, and it uses flows, overlay flows, between the compute nodes in order to represent those applications. So as a result, it can stretch and sit wherever the SDN is deployed. In our case, AWS, GCP, Azure, and our on-prem DC. So in our laboratory, we added Contrail as the CNI for Kubernetes. We used a CNI.yaml for that, so it's a one-line deployer that then builds a high available cluster of SDN controllers that can do all of the use cases that you see in this video series. And of course, being Juniper, we have a lot of telemetry baked into Contrail. We have Contrail Analytics, so the SDN runs an analytics engine that, for example, logs flows, so you can go back in time and see what happened in the past. We have HealthBot, we have Contrail Insights, and in these videos we'll be showing you how to extract telemetry directly using Prometheus Grafana. So this is an open source implementation of analytics. So we can implement security to the edge all the way to where the applications plug into the SDN, and that's a consistent security policy no matter where the SDN sits. So if, for example, you developed an application called MySQL and you generated a security policy for MySQL, that security policy will then be deployed regardless of where the MySQL application sits. GCP, Azure, Amazon, on-prem, or even another public cloud. So in these videos we're focusing on Kubernetes, but of course we can also plug into VMware, OpenStack, or customized orchestrators. The controllers in each of those orchestrators can then be peered so that the same networks can exist across them. So you can do this, for example, with multiple Kubernetes clusters with their CNI controllers federated or peered into each other. And most important of all, your applications don't even need to know they exist. So the architecture uses plugins, and the job of plugins is to make the SDN invisible. So your existing applications are still going to work. Your application developers are just going to see that your network services got a lot more scalable. Your security teams will get new levels of visibility no matter where those applications get deployed. So hopefully you're hungry for more. We've put up a few QR codes that will send you off to additional videos and documentation. Please do check back to this channel because we'll be adding more deep dives in the near future. Thanks for your time.